Hey, it's Jag. It's a preamp.
Yeah.
Today I finally get the circuit card installed. I get everything wired up. The whole preamp is going to be done today and ready for testing. I won't be firing it up today. The testing is going to be a whole video in itself, and so that will be the next video in this series. So without any more delay, let's get to the wiring. Today I want to install the circuit card back into the chassis, but before I do that, I have a couple of things to take care of. I need to take this ground wire out of this eyelet here, and then run it under the board over to pin 3 of the transformer, as I talked about in a previous video. So that's the first thing I'm doing. So I've got those eyelets cleared. This one here, which is at the other end of C7, and this one here, which is pin 3 of the isolation transformer. The other original ground wire is staying in there, so I just need to make a short jumper to go from this eyelet to this eyelet. I'm hoping not to have to take the transformer right out. It looks like I've got just enough room to hook a jumper in there. When you do jumpers, you can leave them bare, like I have with this one, or leave them with the insulation jacket on, like I have with this one. Generally, if I've got to go any sort of travel, like with this blue one, I will leave the insulation on. If it's just a short jumper, then I don't worry about it because there's nothing it could short on in the middle here. This one, if it got bumped, could actually short to that one. Same with this one. It's the jumper has to go from here all the way to here, and it's got a few places that if it were bare, it could short on. So I'm going to leave the insulation jacket on this jumper that I'm making. I want the jumper to travel from the one eyelet to the other. I want it to go from here to here and go in between these two eyelets or these two eyelets. Because I'm leaving the insulation on, it's not such a big deal. But if I keep this wire away from other points, it I think is just a little bit better in case something happened to nick the wire or cause it to wear through or something. We'll cut that down and get that soldered in. It looks like I'm not going to have a lot of trouble hooking this one into this eyelet here, except for this darn splint. That's in there right now, looking pretty good. So we'll just we'll get that one soldered in, and then this one I can bend and I can poke through here. That's looking pretty good. And I'm going to turn this over and solder it on the top side. And that's that jumper done now, going from this eyelet to pin 3. So from here to here, and then off to ground through this green wire up here. We're almost ready to put this card back in the chassis, but I have one other thing I want to do before I do that, which is wire the input jack. So if you can see on the layout here, we have the input jack. We have input, hot input coming, or tip in of the input coming from this terminal, going through coax all the way to this terminal strip over here. We also have the ground shield, which will only be grounded at this end, and that is going to ground from this pin to our store point in the chassis. We also have R1, which is a 1 meg, which goes between the input to ground. So we need to install this resistor, this link. I need to put the coax in, and I need to put a wire, a grounding wire, which will eventually go to the board, and then to the star point from the board, where these other 3 grounds are. So this is kind of a sub star point, we'll call it, and then it's just going to ground here once we get the card in. So that's what I'm doing next. I've installed that 1 meg resistor. It's right here on the side of the input jack, and I've wrapped it around the terminal for the tip and the other end around this terminal or tab, which then goes over to this terminal. This will be our ground terminal. And then I've got the ground wire coming off there. So I'm going to solder this end right now and then cut off this flying lead. And then I've got to, I'll just tack these two on, cut this flying lead, and then I've got to solder on the coax that will go off to the tube. So usually when I'm tinning the shield, I try to avoid getting the soldering iron too close to the inner conductor so I don't melt the jacket on it. Usually enough heat will go through the soldering iron or through the wire from the soldering iron that you can usually tin it the last eighth of an inch toward that inner core, and you won't melt the jacket on the inner conductor. Now when I put this on, I'm going to solder it so that the ground conductor is close to this pin, and then the lead for the hot has to sort of fly over. That way, again, we don't have potential for any sort of shorting. Now, it can be really tricky and fiddly doing this. I find that it really works well to sort of pre-crimp everything. I'm going to solder the ground connection on first. I can just use a pair of pliers and crimp this onto there. These particular jacks, they don't have holes in the lugs. They're actually made to be PC board mounted jacks. So I've got to kind of be a little careful about how I crimp this on, get everything set, and then get on and off with the solder pretty quick, but we want a good solid connection. I don't really like using those PC board, the jacks intended for PC board mounting. I don't like using them for this, but it's what I have. I didn't notice before, and this will work just fine. Once you get it soldered, it's okay. It's just a little more tricky to get everything to stay on the pins. So I do have this wired now. So there, that's that all soldered up. So we've got our hot, the tip here with our hot wire coming from our coax to there. We also have our 1 meg resistor going from there to ground. We also have ground jumpering over to here for the shield for the coax cable and for the ground that will go off to our star ground. So next thing I'm going to do is just check that nothing is shorted in any way it shouldn't be. In other words, I'm going to check that this jack is doing what we expect. So now we've got the jack wired, and we just need to beep it out and check that the connections are working the way they should. So right now there's nothing plugged into the jack, so all of our all of our pins should beep. Everything should be connected to ground. So I'm going to just connect the ground connection of my meter to the ground on the jack, which is this jack right here. So we should get a beep all the way along the path here. So there, we're getting a beep. You can see the green light. We should get it here, and we are. We should get it at the end of the shield that's going to be at the tube, and we are. And we should get it at the end that's going to be going into the tube as well, the positive side. We also should get it on the tip connection of the input jack. So right now, that's the way it should be working. It's doing what it should. It's a shorting jack, and tip should short to ground, and all of our other grounds should connect. Once we connect a jack to it. We should see continuity from tip of the jack to the tip connection on the input jack and to where the input to the tube will be. But we should not have any cross connections on our ground. All of our ground should have continuity all the way through, but we should have no connection between our positive and our ground, or our tip and our ground. So we're going to check that out now. So first of all, I'll leave this on ground. I should not get a beep when I connect to positive or to the tip of the jack, and I don't, but I should on the shield, and I do. I also should not have any beep when I connect to the tip connection on the jack, and I don't, or to the send that will go into the tube, and I don't. So we're looking good there. But our ground should go all the way through. We've already checked that. We should have a good ground connection here, and we should have a good ground connection to the shield. Now, when we wire this in, the shield is already grounded at this end, so we will not be using this. I'm just doing this so I can test for the beeping. When we connect this, there'll be heat shrink over here, and this shield will be unconnected, so we'll be cutting that short and heat shrinking over it. The only thing that will connect is the send into the tube. Since we have this 1 meg resistor from tip to ground, we should be able to read 1 meg on our meter from between the input side and ground. So I'll just do that here. It's giving us our 1 meg to ground. We're actually at about 992, 993 ohms, but that's close enough. So everything looks like it's working with the jack the way it should. So now we're ready to put that into the chassis and start wiring up the circuit card. I was just editing this video, and I got to the part where I was wiring the input jack, and I don't think I did a good enough job describing how that works. It's a shorting jack, so that when nothing is plugged in, the input side of the signal is shorted to ground, so we don't have a floating input making lots of noise. I started doing a little add-on part for this video to sort of describe that and how it worked, and I realized this is material for a whole other video. So stay tuned. I'll be doing a tech tips video talking about how that and a few other sort of jack switches work. So for now, enjoy the video and look for that tech video. It should be coming out soon. So it's a little tight getting this card in, so I might have a little bit of a struggle. Hopefully not. I just want to put this in again without bending all of the wires that I put in too much, because they are solid core and they are anchored at one end, so we don't want to break any of those. It's happened and it's not hard to deal with. It's just a bit of an added pain. So that's going to sit in there. This is going to be a little bit fiddly, especially with this splint on my finger. Okay, not too bad. Got that screw started in there. This preamp may be a one-off, or I may make more of them. If it's a one-off, it's a one-off. If I make more, it's kind of a prototype. So one thing I will do, if I make this again, I won't put the card quite so close to the front. I think I mounted it so the front edge is about a ½ an inch in. Probably would have been better to go 3/4 or an inch. So probably would have worked better to have this card about ½ an inch more toward the back. But this will work just fine. It's just tight for soldering, that's all. Card mounted pretty easily. I'll just tighten things up here, and it's time to start wiring. I think the first thing I'm going to do is wire our shared ground from here, here, and here to our star ground. So these are jumpered, so they're part of that star. I'm also going to take the ground from the input jack and go to here, and I have this bus wire going to the star ground. So this still qualifies as a star ground. This is connected by a wire to here, and then to the star ground. And this will be connected here and then to the star ground. So everything terminates to the same point and ground on the chassis, which is down here just behind the circuit card. That's also where this bus bar is grounding to the chassis as well. So I'm going to take the bus wire that's going to the star ground and put that in, and then the last thing I'm going to put in is going to be this ground wire from the input jack. See how long this splint lasts right now. It's starting to really become inconvenient. Okay, there we go. So since we're at this end, what I'm going to do is wire all of these white wires that go to the front panel controls. I need a jumper that goes from the middle lug of the bass pot over to the low end of the treble pot. I have another one that needs to go from the low side of the bass pot to the middle of the middle pot, and one that goes from the middle of the treble pot to the output of the volume pot. So I'm going to make those three jumpers and get them in place first. The other end of that jumper also needs the connection to C5, which is this wire up to that middle lug on the bass pot. Now we need a jumper from the low side of the bass pot to the middle of the middle pot. The wire coming from C4, this one right here, needs to go to the middle of the middle pot. Also, we need to install a jumper from the middle of the middle pot to the low side of the bass pot. This wire coming from C4 down here needs to go to the high side, I call it, of the treble pot. We need a jumper to go from the middle of the treble pot to the high side of the volume pot. This wire goes to the transformer from the middle of the volume pot. Well, it's about a week later. I got the splint off. Finger still jams up once in a while and it aches just a little bit, but it's much better. But I had to take a break. I got most of the preamp wired. I got all the front panel controls wired. I got the tube socket wired and a little bit of the power end of it wired. And then just had to take a break. So I'm back to it now after a week. And I'm just going to finish wiring the preamp and get it test ready. Next thing I'm going to wire up is going to be the XLR output jack. So I need to wire the ground from here to pin 1. I also need to put a ground jumper to the ground lift switch. I also need to wire pin 2, this red wire, and pin 3, the black wire. So I'm going to solder in these 4 wires next. All right, that's the XLR jack wired. The next thing I need to do is wire the unbalanced output jack. So we have a blue wire, which will come to here, a green wire, which will come to here, also a green wire from the switch here, and then we are going to link this across to this terminal and send that to ground. So we got blue wire here, green wire here, green wire here, link, and green wire to ground. And it's going to be easier to wire this particular jack out of the chassis. So I'm going to take it out, do the wiring, and then we'll put it back in. So I'll need to be careful about my wire lengths so that I can set the runs where they need to go. Now I could use my third hands octopus to hold this jack while I solder it, but I sometimes find that inconvenient because as I'm soldering, things might shift around, the third hands might shift around, the chassis might, and it can really mess with what you're trying to do. So often what I like to do is just take a little piece of cardboard and just make a little jig for the jack that I'm soldering, and then I can just tape it to the chassis and have the jack roughly in place where it's going to go. You'll see that in a minute. Usually take a piece of cardboard 2.5, 3 inches long by about 1 inch wide, and then I'll just put a hole in it that the jack can fit through. Once I've done that, I can put the jack in there. I usually do screw put the nut on as well, just to keep the jack from spinning in that jig. And there I have a little jig with the jack in it. I'm going to just set it here and put a little strip of tape across it to keep it secured to the chassis, and then I can do my soldering. So we're going to need this green wire to come here and connect to this terminal. We'll also need a jumper wire, green, from this end of the lift switch to this same terminal, and we're going to have a jumper across, and then we'll have a green wire going from this terminal to our ground on our terminal strip here. Also, if your wire's crooked and you really want to get it straight, here's another little tip. You can put it on a flat top, take a piece of wood, and just roll it. And that will straighten it up pretty well anyway. So I'm going to connect the green wire from the board, this wire that jumpers over to the switch, our link, and the wire that will jumper over to ground. I'm going to solder all of those onto the jack. I'm not going to solder the jumper going to ground or the jumper going over to the switch or the hot input until after we put the jack back in. So basically I'm prepping this jack, and then I'll install it and final solder the last 3 connections. Okay, I got those all soldered on. That is super finicky. Like I said, these are actually PC board mounted jacks, so they don't have the little holes, the slightly larger terminals with the holes in them. So I had to crimp everything around and then get it soldered on, and that's a lot more work. As I said, it's just what I have and it's what I'm working with. It's fine now, but next time I do this, I'm going to make sure I get the right model of jack. Well, that's most of it done now. I just have to wire the incoming power for the DC jack, the power switch, the jack for the edge lighting, and the switch for the on-off of the edge lights themselves. So I thought I'd just take a couple minutes to show off my collection of rainforest centipedes. I twisted up some wire off camera, and so we need to send power from the DC input jack to the power switch. Then we need to send power from the power switch back over to our power terminal strip, we'll call it. And finally, I need to send power to the strip lights for the edge lighting, and a couple of little jumpers, and we'll be testing ready. There's the preamp all wired up, ready for testing. I don't have time to test today, so that's going to have to wait till the next video. In the next video, I will do beep tests to make sure all the connections are going where they need to go and that the switches are still working properly and nothing has shorted or gone open. I will then power it up without the tube in and just check that all the voltages are getting where we need them. Test the edge lighting and the switch for the edge lighting, the on-off power switch, And then if that's all looking good, we'll put the tube in and we'll run a signal into it from my test signal generator and see what it looks like on the oscilloscope. So that's it for this one. Like always, please check my band One Soul Thrust. The links are in the description below. Thanks for watching. If you enjoyed this video, please give it a like. It doesn't cost you anything or take any time. And until the next video, we'll see you.